Hey mathematicians, it's Justin again. It feels fantastic to have finished my first triathlon, thanks to your help. And now we have a ton of exciting information to analyze from the race, like what was the most common race time for the top finishers, or how many kilometers did athletes complete during training, and how do we make sense out of all of this data? That's exactly what we're going to explore today. By the end of today's lesson, you'll be able to organize and analyze data to find patterns and determine the best way to display it on a graph. Have your guided notes ready? And let's explore the triathlon data. Here's a list of all the finishing times for the triathlon for the top 50 competitors. Whoa, that's a lot of numbers. What's the most common finishing time? Yeah, it's kind of hard to tell just by looking at a table with this much information. How could we organize this data to make it easier to read? Graphs are a great way to display information visually. You might already be familiar with bar graphs and line plots. No matter which type of graph we use, though, we need to group and show the data, or collection of information, in a way that can be easily interpreted and understood. So we'll create a bar graph together to help us clearly spot patterns, like the most common finishing time. Bar graphs use rectangular bars to show and compare data. The graph's y-axis, the vertical line, will show how many athletes finished in each time group. But how high does that number need to go? Since there are 50 competitors, you might think we need to go all the way up to 50, but we should always analyze our data set before deciding. What do you notice about the fastest and longest finishing times? The fastest triathlon time was 141 minutes, while the longest was 208 minutes. The range is the difference between the largest and smallest number in a dataset. Pause here to find the range by subtracting 141 from 208. Our range, or the difference between 141 minutes and 208 minutes, is 67 minutes. To display this data, we use the x-axis, the line on the graph that runs horizontally from left to right, to show the time intervals. The x-axis tells us what categories we're measuring. Since the x-axis shows time intervals, groups of minutes, we'll call those intervals our categories. Now we need to figure out how many athletes finished in each time interval. For example, how many athletes finished between 140 and 149 minutes? Yeah, 4. How many athletes finished between 150 and 159 minutes? Yep, 7. Pause here to finish grouping the athletes in 10-minute intervals on the frequency chart in your guided notes. Does your data set match mine? Great. Now that we've grouped all the athletes into categories, let's figure out the scale for the y-axis. We have data for a total of 50 athletes, but what's the highest number of finishers in any one-time category? 25. 25 athletes finished between 170 and 179 minutes. Most of the other categories had less than 10 athletes. So do we really need our y-axis to go all the way up to 50? Nope, we just need it to go far enough to show the tallest bar, which in this case is 25. But how should we count? Listing every single athlete might be too crowded, but using numbers that are too far apart might make it hard to see important details. What would be a reasonable way to organize our numbers? Counting by 2s, 5s, 10s? Choosing the right intervals helps us see patterns clearly without cluttering the graph. This process of adjusting how we count along the y-axis is called choosing a scale. We're not changing the data, we're just deciding how to space out the numbers so we can fit all the information neatly on our graph. Because our tallest bar represents 25 athletes, we'll count by 2s to label the y-axis. That gives us enough detail to see small differences between categories while keeping things neat. Now that we have our scale for the y-axis and categories for the x-axis, we can set up the rest of the bar graph to visually compare the finishing times. Just looking at the graph, which time category has the most finishers? The tallest bar represents the most common finishing time among the top 50 competitors. In this case, 25 athletes finished between 170 and 179 minutes. Since 25 athletes finished within this time category and no other bars come close, we can confidently say that around 170 minutes was the most frequent finishing time. This is called the mode, the number or category that appears most often in a data set. Because the 170s category has the highest number of finishers, it represents the mode of our data. Great work analyzing the triathlon finishing times, but race day isn't the only important data we can examine. Competitors train for months leading up to the event, and their training patterns can tell us a lot about their preparation. Let's take a closer look. Here's a data set showing the total meters competitors swam each week on average during training. But before we create a graph, we should really analyze the data ourselves. Pause here to determine the shortest and longest training distances and the difference between them, or the range. Record your thinking in your guided notes. The least amount of meters trained per week, or shortest distance, was 1,000 meters, and the highest amount was 3,500 meters. This shows us a range of 2,500 meters. With a range of 2,500, we need a scale with bigger intervals to display our data clearly. Do you think we should skip count or set a scale that goes by 50s, 100s, or 500s? Since these are large numbers over 1,000, using a large scale, such as skip counting by 500, is best. Pause here to set up the scale on the y-axis on the graph in your guided notes. Does your graph look like mine so far? Great. We have 12 weeks worth of data, so on the x-axis, we're going to label each week leading up to the race as its own category and graph the data. This will help us visualize the training over time. 12 weeks before the race, athletes swam 1,250 meters per week. 11 weeks and 10 weeks before the race, athletes swam 1,500 meters per week. Pause here to complete the rest of the bar graph in your guided notes. Check that your graph matches the completed swim training bar graph shown. What is the most common training distance, or the mode, of this data set? 2,000 meters shows up 3 times, more than any other training distance, so it's the mode. Do you notice any patterns in the data? The height of the bars tells us a lot of competitors kept a steady pace with their training, with a few higher weeks and one low week right before the race. By spotting this pattern, we can guess that consistent training played a key role in preparing for the race. It's amazing how much a simple graph can reveal about effort and progress over time. Nice work analyzing the data, determining an appropriate scale, and identifying the mode across these data sets. So, what have we learned today, besides the fact that training for a triathlon requires a lot of dedication? Well, now you know that graphs help us display, organize, and analyze data to find patterns, compare information, and draw conclusions. You analyze data to find the mode, the value or category that appears most often, and use the range to help determine a scale that made your graph clear and easy to read. Be sure to complete the practice questions and extension activities that go with this lesson to practice your skills in analyzing and representing data. And remember, mathematicians, in math, as in life, every effort adds to your success. I'll see you next time.